Factorising this expression, we notice that the common factor between these two terms is x plus 1 that appears in both of them. Since x plus 1 appears in both, that means we can factorise out x plus 1 at the front. And then we think, what do we have to multiply x plus 1 by to get this expression? We have to multiply it by 3x and x plus 1. And what do we have to multiply this side by to get 5x plus 1? We need to multiply it by 5. If you imagine expanding this, we would get 3x, x plus 1, x plus 1, which is this, and minus 5x plus 1, which is this. We could simplify this down a little bit further inside that second bracket, where we get 3x squared plus 3x minus 5. On the right hand side, we're going to do something very similar, but this time we have a few more bits that we can factorise out. First of all, we notice that we have an x in both sides. And secondly, we notice that we have on this bit x minus 2 cubed and on this bit x minus 2 squared, which means we can factorise out x minus 2 squared, as that is the highest power that is in both parts. So outside the bracket this time is going to go x brackets x minus 2 squared, and then inside, what do we need to multiply x minus 2 squared by to get this? It would be by 1/3, and we need an extra x minus 2. And for this one, what do we need to multiply x minus 2 squared by? We need to multiply it by 2, and we need an extra x because there's x squared. We already have all of the x minus 2 squared. We could simplify this by expanding, but what I might choose to do here is actually factorise that 1/3 out as well. So I might choose to make this 1/3, or even x over 3, x minus 2 squared. Now in this first bit I've got x minus 2, but now this second bit is no longer going to be 2x, it's going to be 6x. Because when I multiply the 6x by x over 3, I will get 2x squared. Now the reason to do that is just to make this bracket a little bit nicer without that fraction. So now we have x over 3, x minus 2 squared, and then we have x plus 6x, which is 7x minus 2. And that would be the nicest factorised form of that expression.